Hey everyone, welcome back to my channel, where we dive into the world of coding and solve some of the toughest problems out there. Today, we're going to tackle a hard problem on LeetCode, called number of ways to assign edge weights to. This problem involves assigning weights to the edges of a tree such that the cost of a path between two nodes is odd. It's a pretty challenging problem. But don't worry, we'll break it down step by step. So, let's first understand what the problem is asking for. We're given a tree, represented as a list of edges, and a list of queries. Each query asks for the number of ways to assign weights to the edges such that the cost of the path between two nodes is odd. The cost of a path is calculated by summing up the weights of the edges in the path. We need to find a way to assign weights to the edges such that this cost is odd. Now, let's talk about the intuition behind this problem. The key insight is to calculate the length of the path between two nodes and then use this information to determine the number of valid weight assignments. Think of it like a game of odd and even. If the length of the path is even, we need to have an odd number of edges with weight 1. If the length is odd, we also need to have an odd number of edges with weight 1. This is because the cost of the path is odd if and only if the number of edges with weight 1 is odd. It's like flipping a coin, where heads represents an edge with weight 1 and tails represents an edge with weight 0. So, how do we approach this problem? First, we build an adjacency list to represent the graph. Then, we perform a depth-first search from the root to assign a depth to each node. This gives us the length of the path between each pair of nodes. Next, we iterate over each query and calculate the length of the path between the two nodes. Finally, we use this length to calculate the number of valid weight assignments. If the length is even, there are 2 to the power of len1 valid assignments. If the length is odd, there are also 2 to the power of len1 valid assignments. Now, let's take a look at the code. We start by defining a function dfs, which performs a depth-first search from a given node. We use this function to assign a depth to each node in the tree. Then, we define a class solution, which contains a function assign_edge_weights. This function takes in the list of edges and queries, and returns a list of results. We first build the adjacency list and assign depths to each node. Then, we iterate over each query and calculate the length of the path between the two nodes. We use the function express to calculate 2 to the power of len1, which gives us the number of valid weight assignments. We use modular exponentiation to efficiently calculate the result modulo 10 to the power of 9 plus 7. So, what's the time and space complexity of this solution? The time complexity is O(n plus q), where n is the number of nodes in the tree and q is the number of queries. This is because we iterate over each node and edge once to build the graph and assign depths, and then iterate over each query to calculate the result. The space complexity is also O(n plus q), because we need to store the adjacency list, depth array, and result array. And that's it for today's problem. I hope you guys learned something new and had fun solving this problem with me. If you have any questions or comments, please leave them below. If you liked the video, please give it a thumbs up, like the video, subscribe, and comment your approach below.